Sounds good. All right. Good afternoon, good day, good morning, everybody. And today I'll be talking on the introduction to subnetting. I'm Michael Bello, and I'll just dive straight into this topic. So our topic for today is subnetting, and the first question that brings is, what is subnetting? So this is just an objective of what we'll be talking about today. We'll talk on what is subnetting, the different classes of IP addresses, the different attributes associated with subnetting, how to create a cheat sheet so we can use to do subnetting calculations, and certain steps how to go about solving subnetting problems. And we'll look at a good number of examples. So just a side note, there's a little bit of math, but not something to be scared of. We'll just do addition, basic addition and subtraction. So before I dive into that, I would like to make it, and I'll request that you get a piece of paper, a pen, you could use your phone as you deem fit.
All right, good. Yeah, Mike, I was a bit worried.
I'll just give it.
Yeah, go ahead, Mike. It's your sound was a bit breaking, but it's better now. Go again. Let's see.
It's better now.
Yeah.
Okay.
Mm-hmm.
All right. So I was just saying, I would ask for everyone to get a piece of paper and a calculator. You could use your phone as you deem fit as well, so we could all participate when we look at some of the examples I have prepared for us over here. So to dive into this, what is subnetting? Subnetting is just the process of taking a big block of an IP address and breaking it down into smaller subnetworks, subnets. Now, each interface is to be placed on a specific subnet. So it has to have a unique subnet to that interface. And to optimize the addressing scheme over the internet or over our network, we want to use a minimal amount of subnets, because if we use more than is necessary, we'll go ahead and waste IP addresses. And with this subnet, once you have your subnet, for you to be able to protect your subnet, you can go ahead and use an access control list. So once you create your subnet, you can use an access control list to protect your subnet from invaders, or you can restrict that from certain parties depending on what you're trying to achieve. And with this, you can go ahead and filter the route through your subnets, because with each subnet, for you to be able to access that subnet, you have to give permission to certain parties to be able to access your subnet. And once you do your route filtering, you can limit who can and cannot access your subnet. So by using subnetting, you can drastically enhance the security, the performance of your subnet, and it would help for you not to waste addresses. So before I dive into subnet, just as Aku had mentioned earlier, some people might not be familiar with what an IP address is. So I just want to touch briefly on what IP address is and the different types of IP addresses. So an IP address is just a unique identifier for a host, and your host can be a computer or a server. So it's just given, just as you have your ID card, you have your ID number attached to it. That ID number identifies you as the individual to, or the individual you are to that ID card. So that is just what an IP address is in a general sense. Now, this is not attached to hardware. It is a software address. So it is attached to the software of the host. An IP addresses consist of 32, and these 32 bits are divided into 4 sectors. You hear people talk about octaves. Those are the different sectors. So each octave is divided into, and dividing that into 4 you have 32 divided by 8, you have 4 different octaves. And below here, we could see an example of a dot decimal IP address, 172.32.36. And below, we could have a binary notation. This binary notation corresponds to this dot decimal. This binary notation corresponds to this dot decimal IP address notation. And below, we have a hexadecimal representation of the same IP address. So we have different IP addresses, which are unique identifiers for a host, which could be a computer or a server. And this IP addresses, they're used to identify the host by giving it 2 different components. You have the host and you have a network. So you have the host, which identifies the origin of the address, and you have the network, which are the components within the communication zone of that network. And this IP addresses can be broken down into subnets, which is what we'll be looking at. And to do that, we use subnet mask, which is used to identify the network and the host. And they're typically written in the IPv4 or the IP version 4. So we have the IPv6 and we have the IPv4. The IPv6 is the new IP version, which we have now because we're running out of the IPv4 version, because a lot of IP addresses are being used and they're using all the IPv4 IP addresses that were available. So they've come up with the IPv6. But for this presentation, I'll be concentrating on the IPv4 only. Okay, so this is a notation of what an IP address looks like. So we have the 172.16.254.1. Now we can see that so this is an octet. So this, we have 8 bits here, 8 bits, 8 bits, and 8 bits. Each of these are called binary digits. And binary digits are the smallest units of the computer information. And they're always represented as zeros or ones. Now, 172 in binary format is written as this. So you have 1010, 1100. And similarly, they've written 16 in a binary format, 254 in a binary format, and 1 in a binary format. So each sector here has 8 bits, and that corresponds to 1 byte. So we have 1 byte, which is equal to 8 bits, and we have all 4 octets, which gives us a total of 32 bits, which correspond to 4 bytes. Now we'll have another down the presentation what it's all about and how they go about using this to calculate the number of IP addresses you have. Because we have 2 to the 0 gives us 1, 2 raised to the power 1 gives us 2, and all the way to 2 raised to the power 7, which gives us 128. And we'll see how that is employed for subnetting calculations. So talking of IP addresses, on the IPv4 scheme, we have 2 types of IP addresses. We have the public and we have the private IP address. Now for private IP address, that is just within your network. And with this IP address type, you're not able to access the internet, or other parties on the internet are not able to access your network. While with the public IP address, it is used on the internet. So you can access the internet and other parties on the internet could access your address or your IP address if you've given them access to your IP address. So just to note here is we have 2 types of IP addresses, the private and the public. Now looking at the public IP addresses, we have different classes of IP addresses. We have the class A, the class B, the class C. We have other IP addresses, the D and the E, but we're focusing just on the A, B, and C. So I previously mentioned we had 4 octaves, which are shown in the picture with the IP address notation. We have 4 octaves. So using this IP address as an example, 192.0.2.0/24. I'll talk more about what the /24 is all about, or what the slash and the number after that is all about. But looking at the different classes of network of IP addresses, we have the class A. As I had previously mentioned, the IP addresses, you have the network and you have the host on an IP address. Now, for the class A, we have 8 network and we have 24 host bits. We know for an IP address, we have a total of 32 bits. So for the class A, we have 8 network bits and we have 34 set for the host. For the class B, we have 16 for the host and we have 16 for the network. And the class C, we have 24 bits set for the network and we have 8 set for the host bits. Now, these are just public IP ranges for the class A, B, and C. I'll show you better in the next slide. Okay, so looking at the different classes of IP addresses, we have class A, B, and C. So class A goes from 1.0.0.0 all the way to 127.255.255.255. And class B goes from 128.0.0.0 to 191.255.255.255. And the class C goes from 192.0.0.0 all the way to 223.255.255.255. We'll look at some examples that would help explain a little more what this is all about. And from these classes, we have this number of network addresses and we have this number of host bits or addresses. Let's see. Okay, so this is just a chart that shows you what the CIDR chart looks like. So if we have, let's say from the previous slide, we have shown an IP address example with the /24. From there, you can calculate the number of bits. So if you have a /24, we know an IP address has 32 bits. Now, if you have a /32, that means you have 32 minus 32, and that gives you 0. So you have 0 bits left. And with a 0 bit, what you have, the number of IP address you have is 2 raised to the power 0, which gives you 1. And similarly, let's take a /30. Let's take a /30. You have a /30. That means you're left with 2 bits. So you have 32 minus 30, which gives you 2. So you have 2 bits. And to calculate the number of IP addresses, you have 2 raised to the power 2, which gives you 4. So that is how you go about calculating the number of IP addresses you have available whenever you have, or you pick a prefix, or the slashes are called prefix. So whenever you pick a certain prefix, you can find out how many IP addresses you have, or how many usable IP addresses you can have from that prefix. Okay. So let's take a look at the concepts of going host bits. So we know we have 32 bits. We have a network and we have a host. We know the network plus the host always gives us 32 bits. So let's say we have a certain number of network bits and we want to subnet a certain number of bits. So what we do is we borrow some from the host bits and we use that to subnet. So we have, let's say we put 16 on the network here. So that leaves us with 16 on the host bits. And if you want to subnet 8, we'll take 8 from the host bits and subnet those 8 bits, leaves 8 on the host bits. At any point in time, we always have 32, or we're supposed to have 32 bits. So adding the network, the subnet, and the host bits, we should always have 32 bits. And just something to note, you always want to use the /32 prefix on your local area networks. Let's say within a closed network, you always want to use a /32 because that gives you enough IP addresses to be able to. And on a wide area network, so that's, let's say you have your house, if considering your house as a local area network and you want to connect to another location, at that point you begin to use a wide area network. So for wide area network, you can use a /30. And taking us to the /32, just as I looked in the chart, a /32, that is considered a loopback address. So that is a single address. You have 32 minus 32, which gives you 0, and 2 raised to the power 0 gives you 1. And with that, you have just a single IP address. Okay, so looking at the example of an IP address 192.0.2.0/24, we can find the number of IP addresses. If we take the prefix 24, we have 2 raised to the 32 minus 24. So 32 minus 24 gives us the number of available bits, which gives us 8. It gives us 8 bits, and 2 raised to the power 8 gives us 256. And we have 256 IP addresses. So those are the number of IP addresses we can get from a /28. Now, we have a network and we have a broadcast IP address. Those 2 IP addresses, you cannot put them on your router. You cannot put your network and your broadcast IP addresses on the router. So with that takes a formula of 2 to the n. It gives us 2 to the n minus 2. So the minus 2, we're taking out the network and the broadcast IP because you do not place those 2 IP addresses on your router. So in this example, we have 256 minus 2, which gives us 254. So we have 254 usable IP addresses. Okay. Yes. So New has a question. New, please go ahead.
Oh, Mike. Thank you. During the previous slide, you mentioned, not the example, you mentioned the concept of borrowing bits. At that point, borrowing host bits, at that point, your voice was quite shaky, so I didn't get that clearly. Would you mind repeating it?
Okay, no problem. So is it this one or this one?
Yeah. No, the next one. Yeah, this one. Host bits are borrowed. You were explaining how host bits are borrowed, and your voice didn't come out clear in that point.
Oh, okay. I guess so. Let me go over there one more time. So can you hear me clearly now?
Thank you. Yeah. Now.
Okay. That's good. Okay. So at this point, I was talking about borrowing host bits. So we know for an IP address, we have 32 bits, and we have a network and we have a host. We have a network and we have a host, and those 2 always add up to 32. So the network and the host always add up to 32. Now, what happens if we want to subnet some bits? What we'll do is we'll take some host bits and we'll subnet those. And whenever we try to subnet, or whenever we want to subnet, we'll still have to keep in mind that the network plus the subnet plus the host is always 32. We always have 32 bits. So let's take, for example, we have a network bits of 16. That leaves the host of 16. So let's say we want to subnet 8 bits. So we have 16 network bits. We have 8 subnet bits, and that leaves 8 for the host bits. So this, the network plus the subnet plus the host must equals 32. So if we have 16 with subnet 8, that leaves the host with 8 bits. And looking at the slash 24, so I was saying it is recommended to always use the slash 24 prefix, local area network link interface. So that's within your local network, you always want to use a slash 24. And a wide area network, so that's when you're leaving your network and you're trying to connect to another network. So within those two networks, in two different areas, you want to use a slash 30. Now for the slash 32, that is a loopback or a manager address. That gives you a single usable IP address. That gives you a single usable IP address because you have 32 bits minus the prefix, which is 32. So you have 32 minus 32, which gives you 0. And if you do 2 raised to the power 0, that gives you 1. So you have just a single IP address for a slash 32. So that's why you have it as the loopback IP address, because you cannot use more than one.
Okay. Thank you very much. That was clear, Mike. Thank you for repeating. But the example, I understood the example, but I just wanted to get clear the concept behind borrowing of bits.
Okay. All right. So for this example, it's spoken about the number of IP addresses from the prefix, how to calculate that. We know the network and the broadcast IP addresses. We do not put that on the router, so we subtract those two IP addresses, which leaves us with 254 usable IP addresses. Now on the AWS platform, AWS reserves the first 4 and the last IP address. So that's a total of 5. So to have the number of usable IP addresses in the AWS platform, we have a 2 to the n minus 5. So the first 4 IP addresses and the last IP address. So in this case, on the AWS platform, we have 256 minus 5, which leaves us with 251 IP addresses. So next, we'll take a look at some of the attributes of subnetting. So when you're talking of subnetting, what are the different attributes we're talking about? We talk about the network ID, the broadcast ID, the first host, the last host, the next network, the number of IP address, and the CIDR subnet. So we'll use this to answer a lot of the subnetting examples we have. So the very first attribute is the network ID. And what is the network ID? That is the first IP address in each subnet. So network ID, the first IP address in each subnet. The broadcast IP is the last IP address in each subnet. The first host is the IP address after the network ID. So you have the network ID, which is the first IP address in each subnet, and your first host is the IP address after the network ID. The last host is the IP address before your broadcast IP. The next network is the IP address after the broadcast IP. And the number of IP addresses is how many IP addresses you have within your subnet. And we can do that using the formula of 2 to the n, or 2 to the 32 minus your prefix. And the CIDR or subnet is just converting between your CIDR and your subnet notations. Okay, so just for everyone who has a pen and a paper, just write this down against the different attributes. So your first host is your network ID plus 1. So your first host is your network ID plus 1. Your last host is your broadcast IP minus 1. The last host is the broadcast IP minus 1. Your next network is your broadcast IP plus 1. Okay, and the number of IP addresses is 2 raised to the power of 32 minus the prefix. 2 raised to the power of 32 minus the prefix. Okay, so I'll repeat these steps and I'll add more. So the first host is the network ID plus 1. The last host is the broadcast IP minus 1. The next network is your broadcast IP plus 1. And your number of IP addresses is 2 to the 32 minus your prefix. Is everyone with me here?
Yes, I am.
What about the others?
Okay.
What about the others?
So we have the network ID. It always begins at 0. And that is, so we have the broadcast IP, which is the network minus 1. So the broadcast IP is the network minus 1. Then the next network minus 1. Okay. So, all right. So now we'll go ahead and create a cheat sheet so we can go ahead and use that for solving our examples. Okay. So take this IP address here, 192.168.100.1. So we have the first octet, the second octet, the third, and the fourth. So the first, the second, the third, and the fourth. And I'd spoken about the bits. So each octet has 8 bits, and each IP address has 32 bits, or 4 bytes. Each octet is 1 byte, and we have 4. So we have 4 bytes and 32 bits. So let's create our own cheat sheet that we use to solve our subnetting problems. So we're going from right to left. So we're going right to left. So we write left to right, but here we're going right to left. So you start with 1 and you double that as you go from right to left. So you have 1, you have 2, you have 4, you have 8, you have 16, you have 32, and you have 128. We'll stop at 128. Is everyone with me here?
Yes.
Okay, so, all right. So we're going from right to left. We have 1 all the way to 128, while doubling that. So 1, 2, 4, 8, 16, 32, 64, 128. Our magic number here is 256. Our magic number is 256. We have our first row where we've gone from 1 all the way to 120. Now, on our second row, 1, we'll take 256 minus 1. Answer 1. We do 256 minus 2, and we'll put the answer below 2. Can you hear me? Hello, can you all hear me?
We didn't get that part. It seems your network was fluctuating, so the audio wasn't that audible. Please, can you repeat?
Okay.
Thank you.
Okay, all right, thank you for the feedback. All right, so we have the first row where we're going from 1 all the way to 128. Now, on our second row, we have our magic number of 256. Now, on the second row, below each number we have on the first row, so we take 256 minus 1, and we put the answer we have below 1 on our second row. So we have 256 minus 1, that gives us 255. So below 1, we'll put 255. And we do 256 minus 2, and we get 254. So we put that number below 2, and we do the same thing all the way to 128. Everybody following along? Okay, so I'll give a few minutes and for everybody to write that down. Okay, so we're good to go? Hello, everyone. Can you hear me?
Yes, Mike.
Okay.
What about the others? Hope you can hear Mike, just to be sure. And hope you figure out what we are doing in case you are writing. If you have a question, feel free to ask, please. Or if you are lost, just feel free to ask. Yeah. Go ahead, Mike. I'm sure. Except there's a question now.
Any questions? Okay. All right. So we have our first row going from 1 to 128. And our second row using our magic number 256, subtracting each number on the first row and putting the answer below the number. So we have below 1, we have 255. Below 2, we have 254. And all the way, we have below 128, we should have 128. Now on the third row, below each corresponding column, we'll begin from the right. We'll begin with a slash 32. So we know we have 32 bits. So we'll begin with a slash 32 and we'll go left. So from right to left, we'll begin with a slash 32 and we go all the way to the column of 128. A slash 32. Below 2, we have a slash 31, a slash 30, a slash 29, 28, 27, 26, and below 128, you should have a slash 25. And if you do that, once you get to a /25, you go back and you continue with a /24 from your right.
Sorry,
So
Mike,
you do that.
I didn't miss that third row.
Oh, okay. So, okay. So for the third row, below below the column of 1, you begin with a /32.
Oh, yeah. Okay.
So you begin with a /32 and you go left. So you go /32 and you're going down. Below 2, you have a /31. Below 4, you have a /30. Below 8 is /29, all the way to a /25 below 128.
Okay.
So the column where you have 128, you should have a /25.
Right. Okay. That's good.
Okay. And once you get to a /25, you go back to your right below 1 and you continue with a /24 and you go all the way down. So you go 24 and you follow the same procedure. You take it down until you get to the end and you come back. You should have a /16. You go all the way to your left and you come back. You should have a /8 and you go all the way to /1. The same page?
Yes, I am. So at the end, we should have a /1.
Yes, so at the end below the column of 128, correct.
Okay.
Okay. Hugo, are you with us? Are we on the same page?
Yes, yes.
Okay. All right. So now if you have space, or you can just make a note. On the first row, on the very first row where you had 1 all the way to 128, that corresponds to your group size. That corresponds to your group size. So we have 1 to 128, that corresponds to your group size. The second row, where you have 255 all the way to 128. So the second row, that corresponds to your subnet mask. So your subnet mask. And the third row, the third row, you have, that is your CIDR. So the third row is your CIDR. The first row is your group size. The second row is your subnet, and the third row is CIDR. Looking at the third row, you should have 4 different rows under that particular section. So when you begin from a /32 all the way to a /1, you should have 4 different rows. The first row on that particular, so looking at that last section where we're focusing on the CIDR, the first row over there corresponds to different octaves. And the very first row corresponds to your 4th octave. So from /32 all the way to /25, that corresponds to your 4th octave. Your /24 to your /17 corresponds to your 3rd octave. Your /16 to your /9 corresponds to your 2nd octave. /8 to your /1 corresponds to your 1st octave. Okay. Are that way on the same page?
Where are the others? But so far,
Titus, are we on the same page here?
I'm sorry, I just came in late, so I can't follow. I'm just listening.
Okay, no problem. Yolande?
Sorry, excuse me, Mike. Are you still creating a cheat sheet? Are you still on that page? Because my recording or my showing hasn't changed so far, so I don't know whether it's my end.
I'm still creating a cheat sheet. Yes, I'm still creating a cheat sheet.
Okay, we're still on that. Okay.
Okay, yes. Okay, so Yolande, are we on the same page here?
We have it lost.
Okay. All right. So on the same page, you should have something that looks like this. You should have something that looks exactly this. So your group sizes from 1 to 20, your subnet mask from 25 to 128, and you have your different Can you all hear me now?
Yes, I can hear you, Mike.
Okay, because I think I'm having some network issue here. All right, so if you were following along, I was saying you should have a sheet that looks exactly like this. So you have your group size from 1 to 128, your subnet mask from 255 to 128, and your CIDR from /32 for the fourth octet to 25, /24 to /17 for the third, /16 to /9 for the second, and /81 for the first. Okay, so now this is where we're solving subnetting problems. So we have a few steps here that will guide us how to go about solving those. So looking at this IP address example, we have a 10.1.1.55/28. We have a CIDR, which is the /28. A target IP octet here. So once you have your /28, looking at your cheat sheet, that falls in the fourth octet. So you can associate your octet or your target IP octet to that CIDR or to that particular octet. Okay. So the steps we use, so the very first step, once you get your prefix, your CIDR, your /28, you can go ahead and find the corresponding column on your cheat sheet, and you do a CIDR set or a subnet mask map to each other. So if you have a /28, you go ahead on your sheet, you look for where you have your /28, and you mark your link column where you have your /28. From there, you can locate your group size. So you have you map your CIDR, you can map that to your group size, and you start at 0 in the relevant octet. You always start at 0 with the relevant octet, and you increase by the group size step size until you go past your target IP. Until you go past your target IP octet value. So the first thing is you get your CIDR, you map it to your cheat sheet, you map it to the corresponding CIDR on your cheat sheet, you locate your group size. You start at 0 and you go in increments of your group size until you go past your target IP octet value. And the next step is the number before or equal to your, so this is where you start associating or putting values to, or you put the different subnetting attributes to the IP address you have. So the number you have before or equal to the target IP is the network. That gives you your network ID. So remember, you've gone past your target IP when you were doing the numbering of increment of your target IP. The number before or equal to your target IP is the network ID. And what did we say your network ID is? That is the first IP address in your network, in your subnet. Okay. So once you've done that, you've located your network ID. The next number after the target IP is your next network. Remember, you were going in increments of your group size. So you're using those increment values. So that number after the target IP is your network. So your next network is the IP address for the subnet after the subnet you're dealing with. The IP address for the network is your broadcast IP. IP address after your network ID, that is your first host, which is your network ID plus 1. So your network ID plus 1 gives you your first host. And the IP address before the last host, the IP address before the broadcast IP is the last host. So we know the IP is the last IP address in your subnet, and the IP address before the broadcast is the last host. And remember, your network and your broadcast, you do not put that on your router. Okay. And for the fourth octet, the group size corresponds to the total number of IP addresses. That is just for the fourth octet. For all the other octets, you have to use the formula I'd shown, which is 2 raised to the power n, and you could do a -2 to get the number of usable IP addresses, since you do not put your network and your broadcast IP on your router. And for AWS, you do 2n -5. Reserve the first 4 and the last IP address. Okay. All right. So let's look at some examples here. So we have a 10.1.1. Step C. All right. So let me go back to step C to the slide. You didn't get the C here. So for step C, on this one, so after you've located your CIDR, you've matched that up on your cheat sheet to the corresponding prefix of the CIDR, the /28. You locate the group size on that column, which is the very first row you have on your cheat sheet. You always start at 0. So your IP addresses always start at 0. So you start at 0 in the relevant octet. So you know you have the first, the second, the third, and the fourth octet. So depending on your area of focus, you do that. You start at 0 at the relevant octet, and you go in increments of your group size. So let's say we have a /28, and we're looking at, if you take a look at your cheat sheet and you match the /28, you're looking at the 16, the column where you have 16. So you go, your group size is 16, and you begin at 0, and you go in increments of your group size, step size. So you go 0, 16, 32, just in that increment.
Okay.
Okay.
Yeah, clear.
All right.
Thank you.
Great. All right. Okay, so that takes us to this one. Anybody has any point I need to clarify on this one, or would like me to clarify? Okay, so I'll take it. Okay, so let's take a look at this example. So I'd like to have everyone work on their cheat sheet as we go along. So we have a .1.1 55/28. Okay, so we have a /28. So if you're going on your CIDR, your /28 gives, it puts you on the column of 16 if you match the /28 CIDR on what you have to your cheat sheet. It gives you the column of 16. So you have a group size of 16. So the two you can fill in is you can put the group size, which is 16, and we said for the 4th octet, the group size corresponds to the number of IP addresses. So we have group size 16, that gives you 16 IP addresses. Now, from here, we know we do not put the ID and the broadcast IP router. So that takes out 2. So we have the number of usable IP addresses, we have 16 minus 2. So that gives us 14. Okay? So that gives us 14. Now, looking at your cheat sheet, we can do the CIDR and the subnet, the CIDR subnet. So we have the /28, and we know we're dealing with the 4th octet here. And we know our magic number is 256. Our magic number is 256, but you do not put that on your octet. So that leaves you at 255. So we have 255 because we're not dealing with this octet. We have 255, we're not dealing with this octet, and we have 255, we're not dealing with this octet. Now, looking at the subnet mask, you have the corresponding subnet for the /28, you have 240. So that leaves us with 240 here. So we already have, so I have our subnet 255.255.255.240. So we have the group size and the number of IP addresses sorted out, the number of usable IP addresses and the CIDR subnet sorted out. Now, we're coming on to this other attributes of the subnetting. So what do we know? We know the group size. And what was the first step, or the step I had asked me to go over is you begin from 0 and you go in increments of your group size. So we'll go from 0 in increments of group size. We have 0, 6, 0, 16, 32, 16. Now keep in mind, our octet or focus is this one, or our target IP octet is 55. So we have to go past that IP octet value, or the target IP octet value we have here, which is 55. So going in increments of 16, we have 0, 16, 32, 48, and 64. Now we see 55 falls between 48 and 64. Everybody with me here?
So if I understand, we go from 0, 16, then 16 plus 16, that would be 32.
Exactly.
Then 32 plus 16.
Plus 16.
48.
48.
48 plus 16. Okay, I get it now.
64, exactly. So we're going in increments of the group size. And our group size for the /28 is 16. So it's exactly as you were saying it. So 0, 16, 32, 48, 64. Now, you notice at 64, you've gone past your target IP octet, which is 55. So we can stop at 64. Now, take note of this. You have 48, you have IP of 55, and you have 64. So your target IP falls between the 48 and the 64. So you set the value before, let me go back to this slide. So the number, so if you're looking at 2 here, we've done all of this, we've gone past our target IP. The number before or equal to target IP is your network ID. Okay, so the number before the target IP, which in this case would be 48, that is our target. That's our network ID. So we know our example is 10.1.1.55/28. Now, our network ID is 10.1.1.48. That is how we get the 48. So that is the number before our target IP. Okay. So we have the dot 48 that gives us a network ID here. And now we have, with the network ID, we know it goes from, so we know the group size goes from 48 to 64 for the network. So for this particular subnet, we know the 64 becomes our next network. 64 is our next network. So we could go ahead and write that as 10.1.1.64 is our next network. So that is the beginning of the next subnet. So from here, we could solve the other attributes. So we have the broadcast IP. What do we say our broadcast IP is? That is the next network minus 1. So that is the last IP in the subnet, or it is the next network minus 1. So we have 64 minus 1. That gives us 63. So that is our broadcast IP. And remember, the network and the broadcast IP, you do not put those on your router. Okay. So we have a broadcast IP. Now for our first host is the first IP after your network ID. So we have the network ID plus 1. So we have 48 plus 1. That gives us 10.1.1.49. And the last host, so that is the last usable IP address. That is one IP address before your broadcast IP. As such, we have the last host being the broadcast IP minus 1. And that gives us 10.1.1.62. Okay, so any questions before we go? We have many more examples, and there's certain things I'll need to point out as we go through the different examples. So any questions? We'll look at another similar example to make sure everyone's speaking what we're talking about. So any questions at this point before we'll keep going with more examples?
Mike, what I just want to recommend and for everyone is that please make sure the key to this is the cheat sheet that Mike explained earlier. If you have problems understanding that, you can ask. And I will just say that I've done subnetting for a very long time in my life, but this is a very good way on how to understand how subnetting works. Once you understand that cheat sheet that Mike produced, then coming up with all these tables and all these figures becomes really straightforward. So if you have questions, I can only encourage you to ask, or maybe if you want to look at the video later, I will say this is a very important lesson on understanding subnetting. But Mike, if there are not questions, maybe you want to just do another example, and then let's see again, maybe it will come. But my recommendation is, yeah, everyone who wants to really understand subnetting to take this serious. Yeah. Yeah. So Mike, maybe you want to do another example and we see again if there are any questions. Yeah. Since I'm not seeing any. I hope, Mike, you can hear me. You're on mute, Mike, in case you are speaking.
So any questions? No, we'll take another example.
Yeah, let's go out through another example and then see if there is any. But it's a very good method. Yeah.
So can everyone hear me?
I hear you.
Yes, at least. Sure.
Yes.
Yeah.
All right. It's 10.2.8/27. Okay. So we have a target IP octet. Well, let's begin with our CIDR, /27. So if you go to your cheat sheet and you match the corresponding CIDR to a /27, that puts you on the column where you have 32 as your first row. So with that, you know your CIDR, you can go ahead and fill in the group size. You have a 32, the group size, which corresponds to the number of IP addresses. Now we know we take out the first, or take out 2 IP addresses, which are the network and the broadcast. So we do leaves us with 30 usable addresses. Still on the same column, of 32, our subnet mask corresponding to that is a 224. Corresponding to a /27 is 224, and we know we're dealing with the 4th octet. So we have 255.255.255.224. So that takes care of the last 3 attributes: the number of IP addresses, number of usable IP addresses, and the CIDR subnet. Now we know we're going from, our group size is 32, so we'll go in increments of our group size. So we'll go 0, 32, 64, 96. Okay, and we know our target IP octet is 88. So at 96, we've already gone past that target IP octet, so we can stop right there. And with that, we can have our next network as 10.2.2.96. So we know that is the next subnet. That is where the next subnet starts. So we have our next network as 10.2.2.96. From there, we know we can find our broadcast IP. Our broadcast IP is 1 IP less than the next network. So it's 10.2.2.95. And from the increment of the group sizes, from the increments of the group size, we had 64 before we had 96, and our target IP octet falls within that range. So we know our network ID begins at 64. So we have 10.2.2.64. And from there, we could find our first host, which is 1 host plus the network, or 1 plus the network ID, which is plus 1 here, we get a 65. So we get 10.2.2.65. And the last host is the broadcast IP minus 1. So that gives us 10.2.2.90. And that takes care of this example. Questions on this one? Any questions, anyone? Any clarifications?
So far, good by me, at least with the cheat sheet I'm getting on well.
Okay. Sounds good. All right. So I'll take no questions. Everybody's following along. Everybody's doing good. All right. So since we're getting a hang of this 4th octet, I'll go ahead and skip the next example, which is very similar to this. And I'll get onto the examples that have something I would like to point out. I'd like to point out as I go. Okay. All right. So take a look at this example here.
Mike, before you continue, I see Judith has her hand up, if you won't mind.
Okay.
Okay, Mike, thank you. I missed out one thing that I didn't follow up. When we can get the size with 32 minus like here 26, and from there I can work the other things. But when I get to 0.8, this cider subnet, the last octet, this 192, I'm not yet clear how to get that one.
To the last octet, 192. So you're saying a slash, excuse me. So you're talking of a slash 26.
Yeah. The other ones I'm fine with, but number 8 on this one.
Okay. That's subnet.
Yeah, subnet.
Okay. All right. So let's touch that really quick. Hopefully that helps. All right, so let's look at this example. So Joe, I'll touch your question as we go along with this example.
Okay.
Okay. All right. So for this example, we're looking at a 10.20 or 10.2.2.199/26. Okay. So our cider here is a /26. So matching that on our cheat sheet, a /26, it takes us all the way to the column where we have a 64 on the very first row. So we have a 64, and that gives us a subnet mask of 192. So that gives us a subnet mask of 192, and we know we're dealing with the fourth octet. So we know we're dealing with the fourth octet. We have nothing to do with the first 3 octets. So that's why we have 255.255.255. That is where we get the 192.
Yeah.
So we have, for the subnet, you have 192.
So that is much more clearer, Mike. If you want to show the cheat sheet, because it is looking in that cheat sheet, or if Drew is looking at her cheat sheet, she'll see that /26 falls under subnet mask.
Okay, right here.
Yeah. So
it's
that
right here.
cheat sheet.
Drew, can you see the cheat sheet on this?
This one, yeah.
Drew, can you see the cheat sheet on the screen?
In case you are speaking, you're on mute, Joe. I can hear you.
Sorry for that. I was speaking, I was on mute. Okay. Yeah, this.
Yes. Okay.
Mm-hmm.
Yes, so here we have so you match the corresponding cider with this. So that's the group size, the first row, and the second is the subnet mask. So that is where we get these values. Okay. So for a /26, that is a /26, and we have 64 groups. The group size is 64, and the subnet mask is 192. So that's how we get that 192 at that point.
Okay, thank you.
Welcome. All right. Okay. So that side of 255, 255, the 255.192. So from here we know our group size. So we have a number of IP addresses, 64. We can get the number of usable IP addresses, 64 minus 2, we get 62. Now remember, if this is AWS, you do -5, not -2. Okay. We do our group size increments. Our group size is 64. We do our group size increments 0, 64, 128, 192. Remember, our target IP octet is 199. Do 0, 64, 128, 192, and 256. Our target 199, we've gone past 199, so we could stop at 256. Remember, we had a magic number of 256. Okay, so you expect, since we've gone past 99, you can go ahead and write the network ID, which is the ID of the beginning subnet, which is the, once you do your group size increment, is the one before, is the one equal or before to the target IP. So in this case, we have 192. So you have 10.2.2.192. So when you go in your increments of 64, you have 0, 64, 128, 192, 256, and your target IP octet 199 falls between 192 and 250. Okay. So your network ID is 10.2.2.192. You have your first host, which is your network ID plus 1. So you just 1 to this, you get 10.2.2.193. You have your next network IP. So after you do the increments, you have your 199, your target octet falls between 192 and 256. This is where the trick comes in. Your 256 is supposed to be your next network. So if you're supposed to write your next network as 10, since you have 256 when you write the increments, as 10.2.2.256. But the thing is, you cannot write it like this. You cannot put 256 in an octet. So what happens in this case? This automatically, or this changes the next octet by a size of 1. And this one becomes 0. So instead of having this, which you cannot do, you have, it becomes 10.2. We had 2 here for the third octet, but we had 256. So this, the third octet increases by 1, and the corresponding fourth octet becomes 0. So you have 10.2.3.0. Everyone following along? Everyone with me here?
Yeah.
Okay, thank you.
Yes, we got it.
So we have,
got it.
thank you.
Great.
The feedback. So we have 10.2.3.0. Now that becomes our next network ID. So from here, we know the broadcast IP is 1 below the next network. So we have 10.2.2.5. Do 256, but we have 255, which is available and we can use. So the broadcast IP is 255. And the last host is 1 below the broadcast IP. So that is this minus 1, and you get 10.2.2.254. And that is how we get the attributes for this subnet. So any questions on this particular example? Want anything before that? Any questions, anyone? All right, I'll take it everybody's following along. All right, so before we get to a few examples, just a few tricks you can use when you're solving subnetting problems. So you can always, when you have your group size, you can always multiply that by 10, and you could double and triple that as need be or as necessary. And each group, each size, it always lands at 128 at some point. Every group size lands on the subnet of the same column and every column to the left. And you can always start higher and subtract as you go. So looking at the sheet, every subnet will always land on 128 at some point in time, or every group size, you always land at 128 at some point in time. And you can always, and this or this group will always land on this set at any given. So subnet on the left, you always land on that. So those are some tricks you can use. And let's say you have a group size of 8. You can always multiply that by 10. Let's say your target IP is 88 and you get on group size 8, you can do that. You can multiply that by 10 such you get 80. And from there, you can just go 80, 88, and you can go to the next, to 96. So those are just some tricks to make solving subnetting problems easier. Okay, all right. So another example here is 10.4.77.188/19/19. So matching this cider to the cheat sheet onto your cheat sheet, you realize the /19 is on the third octet. So a /19 is on your third octet, and that makes this one your target IP octet. So 77 becomes your area of focus. So as such, you can get the number of addresses. As I had mentioned before, the group size corresponds to the number of IP addresses only for the fourth octet. For any other octet, you have to do 2 raised to the power of 32 minus your cider. So for this case, we'll have a /19. So you do, for your number of IP addresses, you have 2 raised to the power of 32 minus 19, which gives you 8,192. And from there, you can get your number of usable IP addresses. You subtract 2 from that, since you're taking out the network and the broadcast IP. That gives you this. And if you're on the AWS platform, you subtract 5 instead. Now we have a /19. Matching that onto your cheat sheet, a /19 puts you under the column of a 32. And the corresponding subnet mask is a 224, which is very similar to a /27. So a /19, the subnet mask is 224. As such, your cider subnet is 255.255. Now remember, you're dealing with the third octet. You have 224 on the third octet. And your last octet is always 0, since you're not dealing with the last octet. At this point, you're dealing with the third octet. So your last octet, or your octet 4, is always 0. So we have these 3 last attributes dealt with. Now we have a group size of 32 going in increments. Remember, your target IP octet is 77, going in increments of 32. You go 0. So we're doing a group size, step size increment. So you go 0, 32, 64, 96. Your target IP is 77, so it falls between 64 and 96. It falls between 64 and 96. 64 and target IP is right in between those two, 7. So that gives you ID, which is the number before the target IP. As such, you have your network ID as 10.4.64. So that's 60. So you have your network ID as 10.4.64. Remember, you're dealing in the third octet, .0. And your next network, which is the IP subnet, start at 96. So you have 10.4.96.0. We're dealing with the third octet. So that's why all these numbers are changing in the third octet. Okay, so from here we have our next network. We find the broadcast IP, which is the last IP before the next network. Remember the previous example where we had a change in octet. So if our next network is 10.4.96.0 and the IP before that, so that means we had a 256, which caused this last octet, will cause the fourth octet to change and or cause the third octet to increase by 1. So that makes the broadcast IP a .95.255. Because if you have a 256, it causes this one to go to a 96. So that is how we get the 95.255 at this point. And the first host is the network ID +1. So you have +1. So you get 10.4.64.1. And you have the last host, which is the broadcast IP -1. So you get 10.4.95.254. Any questions on this one?
Since we're, I don't see anyone raising a question, but please, if you have a question, just try to prepare this and share. I know we're already running out of time, Mike, but just try to round up and let's say if there are questions, we can do more exercises again. I think in another session, I think it wouldn't be a bad idea. Yeah, if people come up with what,
amazing.
Yeah, so if people review the video, review what you've had, and can't do examples, I'll encourage they send those questions, and then we try to do another example session. Yeah.
Sorry, I have a question for Mike.
Go ahead.
For this slide now, this third octet. Sorry, can you repeat how you got that ID, network ID again? For this slide we are on. How do you get?
Okay, so let me go over there real quick.
Thank you.
Okay. All right. So you remember the point where you do the group size step increments. So if you're looking at your side at /19, that gives you the group size of 32. So the group size is 32. So you go in group size step increments. So you begin 0, 0, 32, 64, 96. Remember your target IP octet here, since we're dealing in the third octet, is 77. So you want to go past your target IP octet, which is 77. So you want to go past that. So going in increments of the group size 32, you have 0, 32, 64. So we can stop there because we've gone past 77. Now, getting the next network, which is the IP for the next subnet. So since you've gone past the target IP, the next increment, the next step size tells you your next network. So looking at increments, you have the 96. As such, you have a 10.4.96. So that is your next network. That is where your next subnet begins. So that is how we get the 96 over here. And since we're dealing with the third octet, that goes in the third octet, and the fourth octet is always 0.
Okay, it's clear now. Thank you.
All right. Okay. All right. So with no questions, let me go ahead and round up, and we'll take questions if any do come up. Okay. All right. So this one too is a third octet. So here we're looking at the third octet again, but just touch some of the tricks or some of the tricks to solve subnetting problem. The third octet, I'll go a little bit faster on this one. So the third octet here, our target IP octet is 253. We have a /21. So looking at your cheat sheet, a /21, that is the third octet that puts you under the group of the group size 8. So you're going in increments of 8. But remember, your target IP octet is 253. So if you have to do increments of 8, it might take you forever. So you can go ahead and do 0, 8. You can do that if you want. But if to just get that pretty quick, you could multiply that by 10. You multiply that by 10, you already have 80. So you have 80. So you can go ahead and multiply that by 2, by 3, by 4. So if you multiply 80 by 2, that gives you 160. You multiply that by 3, that gives you 240. and you see that you've already gone past 235. You've already gone past 235, so you don't need to keep going. So you multiply 80 by 3, that gives you 240. So you can stop right there. Now, you know you're going in increments of 8. You're going in increments of your group size, which is 8. So if you've gotten to 240, which is past 235, you can go back, you can subtract 8 from that, and that gives you 232. And your 235 falls between those two values, between 232 and 240. Now, with those two values, you can get your network ID and you can get your next network. So with your network ID, which will be the address before your target IP, so you get 10.4.232.0. And your next network is 10.4.240.0. Remember, we're dealing in the third octet. We're dealing in the third octet. For your number of IP addresses, you have a /21. So you can do 2 raised to the power of 32 minus 21, which is 2 raised to the power of 11. And that gives you this. The number of usable IP addresses is this minus 2, which gives you this. Now, from a /21, your CIDR is, your subnet mask is 248. So in the third octet, you have a 255.255.248, third octet. So the fourth bit is 0, so you have a .0. So from here, we have our next network. We have our network ID, attributes. Broadcast IP is the last IP for the next network. Remember, if this is 0 and this is this, so to get to this one, that means we had a 256. That means we had a 256 and a 239 for this to become 240 and a 0. As such, we do not put a 256 on our network. So as such, our broadcast IP is 10.4.239.255. And our first host is 1 plus the network ID, which is this plus 1. So we get 10.4.232.1. And our last host is the broadcast IP minus 1. So we get 10.4.239.254. So that takes care of this IP range. And we have the second IP, for the second octet. But now the 12, with the /12 side, as we're looking at this example with the /12, matching that to your cheat sheet, you know you're dealing in the second octet. And in the second octet, so you have nothing to do with the third and the fourth octet as such, that is 0. So you have a /12, the subnet mask corresponding to that is on the column of the group size 16, which is 240. So you have 240.0. Because the second octet. And usable IP address, your IP address is 32 minus 12, which is 2 to the 20. And usable IP is that 2 to the 20 minus 2. So you get number of usable IP addresses 2 to the 20 minus 2, and that gives you that. So to get your network ID and your network ID and your next network, we're dealing with a /12 that puts you on group size 16. So you do your increments in sizes of 16. You can multiply this as necessary. So your target IP is 50. So you want to do group size step increments, go past 50. So if you do 0, 16, you can do that. Or you could multiply, if you multiply 16 by 3, you get 46, and you do by 4, you get 64. So you've already gone past the target IP of 50. So you're between 46 and 64. So that gives you your network ID. It's your next network of 10.64. That gives you your next network of 10.64. So let's pass 50. So you get 10.64.0. because you're not dealing with the third and the octave. And your next ID, your network ID, that is before your target IP octet, which is your target IP octet is 50, and below that 16 times 3 is 40. So 10.48.0. And from there you can find your broadcast. If you have network, your next network of 10.64.0.0. Remember, if it is 64.0.0, that means this had to change for this to change. So you had a 63 here, and you had a 255 and a 255. So as such, your broadcast IP is 10.63, 255, the 255. And your first host is your network ID plus 1, which is 10.48.0.1. And your last host is your broadcast IP minus 1, which is 10.63.255.254. Okay. And the last is, so this next example has to do with the fourth octave. So similarly to the other ones, we're looking at the first octave. So you have nothing, /7. A /7, that puts you on the first octave, column corresponding to 2. And that gives you a subnet mask of 254. And since you're dealing with the first octave, you have 254.0.0.0. You have nothing to do with the second, third, and fourth octaves. And you can find your number of IP addresses 2 to the 32 minus 7, which is 2 to the 20 to the 25, 25th. And you have number of usable IP addresses, which is 2 to the 25 minus 2, since you're taking out your network and your broadcast IP. After 10.50.1.1.22/7, since we're dealing with group size, that is a /7, column 2, column under 2, you're going in increments of 2s. So if you do increments of 2s, your target IP octet is 10. So you want to go past 10. So if you do 2 to the 5, that gives you 10, or 2 times 5, that gives you 10, 2 times 6, that gives you 12. So you know your target IP is between 10 and 12. So as such, your next network will be the one past your target IP, which will be 12. So you get 12.0.0.0, since you're dealing in the first octave. Now to get your network ID, that will be, let's say, is the one before or equal to your target IP. You have network ID is 10.0.0.0. Now your broadcast IP is 1 minus your network, your next network. So we have the broadcast, our next network is 12.0.0.0. For you to have 12 here, that means you had a 256 over here for this to change. So you had 256 become, this one changed, became 256, this one changed, became 256, and this one, and it changed for it to become 12. As such, you have your last host will be 11 to 5, your broadcast IP will be 11.255.255.255. Because once you go 256, it changes to 0, and this one increases by 1. The next octet increases by 1, and this becomes a 256. It changes to 0, and this one increases by 1. It becomes a 256, and this becomes 12. So that is how you have your next network. So from your broadcast, which is, if you subtract 1, you get your last host. So you get this for your last host, and your first host is your network ID. ID plus 1. So as such, we have 10.0.0.1. So with this one, I'll just go ahead and okay. So let me go ahead and point out something on this last one, and we'll call it a day for the session. So on this example here, we have a /2, which puts us under the 64, the column of 64. So from here, we can solve a number of IP addresses. We can get the number of usable IP addresses. We can get the CIDR because the sum corresponds to 192, and we're dealing with the first octet. So we have 192.0.0.0. Now, if we go in increments, the group size is 64. If we go in increments of 64, we have 64 times 3, which gives us 192, and 64 times 4 gives us 256. So we're supposed to have 256. So our target IP is 213. And if the next network is supposed to be 256, remember I mentioned we cannot put 256 on a network. So if our next network is supposed to be 256, so in this case, we don't have a next network. The next network becomes unavailable or is not applicable in this case. And with this, we can go ahead and have the broadcast IP as the IP before the next network, which is 255.255.255.255. And the last host, which is 1 minus the broadcast minus 1, which is this. And we have the first host, which is the network ID. We had 192, then 256. So we have 192.0.0.0, and the first host becomes the network ID plus 1. So that's how we'll go ahead solving this attribute in this particular example. Note we do not have a next network. So with that, I would just like to summarize what we looked at. We looked at the different octets and how they're affected during the subnet calculations. We looked at how an IP address is written in the decimal notations and the binary notations, noting that each octet has 8, and we have 4 different octets, giving us a total of 32 bits or 4 bytes. So with that, I know I'd mentioned briefly at the beginning about IP addresses, but here are some links to some YouTube videos where you could watch and get some more information about IP addresses. So with that, that brings us to the end of the session, and we'll take questions. Thank you for your time and attention.
Yeah, I hope everyone is there. Great, Mike. Thanks. Anyone has a question or a worry? My recommendation would be that if you didn't follow this, please go ahead and watch the recording. Please go ahead and watch the recording. Try to do the examples by yourself. And then if you have questions, just bring them up, and then we'll look into that, because it's already 20 minutes past 10 p.m. And I know it's definitely late for some other people. But what I'll say is subnetting, this was a great method of subnetting from Mike. I've never seen this. I've been doing subnetting for many years, but this is a very good one. And the key thing is the cheat sheet that Mike had. So learn how to have that cheat sheet, learn how to do the examples. And if you have questions, please just bring them up. That's the only way you can learn, but you have to try to do it first, because you cannot just have it just by any magic. You have to practice it. So any comments before we go or before we run up? I see some people are saying that. Thank you, Mike. So please.
Thank you very much, Mike, for the presentation. Well, at one point I got lost, but I think I really have to go again through the video. Then maybe I can get more understanding. Thank you for your time.
Thanks so much, everyone. And just as Brandon mentioned, any questions, just reach out and we'll start about it.
Nice. Thank you so much for your time, Mike. And as Uncle Van mentioned, the cheat sheet really did help me. I mean, that's the first time I'm coming across such a cheat sheet, and it helped me understand the examples and could follow that along. Thank you once more.
All right. With no more comments or suggestions, thank you very much, Mike, for this session, for coming up to contribute to the community. Really appreciate. I think, yeah, let's leave it here. And please, this is a very important part in your to understand networking. I'm glad those of you were able to come up and listen to this. I will say take it forward. I think Mike will share the PDF and try to practice this. And then, yeah, let's come back to it if you have questions. But apart from that, yeah, everyone have a good evening and a good afternoon for you, Mike. And yeah, good luck to all those taking the exams and those preparing. I know many people, some have registered, some are taking. So both the practitioner and solutions architect. So good luck, everyone, and see you again on chat or next week. Yeah, you're welcome. Okay.
Thank you. Thanks, everyone.
Thank you.
Thanks. Bye.
Thank you. Bye.